Free energy. Gibbs free energy predicts spontaneity. We use the symbol delta G for the Gibbs free energy. It equals the change in enthalpy minus the temperature, absolute, times the change in entropy. Delta G will be less than 0, that is negative, for a spontaneous reaction. Delta G will be greater than 0, positive, for a non-spontaneous reaction, and delta G will equal 0 for a reaction at equilibrium. For a reaction under standard conditions, delta G super 0 equals delta H super 0 minus T delta S super 0. It's referred to as the standard free energy change. The standard free energy of reaction, delta G super 0 of reaction, is the free energy change for a reaction when it occurs under standard conditions. Again, a hypothetical reaction, the delta G of reaction will be equal to C moles times the change in the free energy of formation of component C plus D moles times the change in free energy of formation of component D minus A moles times delta G super 0 of formation for component A plus B moles of delta G super 0 formation component B. That is, again, products minus reactants. The standard free energy of formation is the free energy change that occurs when 1 mole of a compound is formed from the elements in their standard states. Delta G super 0 sub F, the free energy of formation under standard conditions of any element in its stable form, is 0. This is like enthalpy, but not like entropy. Remember, there is entropy for all substances, including elements in the stable form. Here are the conventions for standard states. A gas has to be at 1 atmosphere, a liquid a pure liquid, a solid a pure solid. For elements, delta G super 0 F equals 0, and solution 1 molar concentration. A table of free energy of formations under standard conditions. What is the standard free energy change for the following reaction at 25 degrees Celsius? 2 moles of benzene reacts with 15 moles of oxygen to yield 12 moles of CO2 and 6 moles of water. Remember, it's the sum of the free energy of formation of the products minus the sum of the free energy of formation of the reactants. Substituting in 12 times the free energy of formation of CO2 plus 6 times the free energy of formation of water minus 2 times the free energy formation of benzene. Again, the free energy of formation of O2 is 0. Substituting in the numbers, this evaluates to be a negative 6,405 kilojoules per mole. Is the reaction spontaneous at 25 degrees? Since delta G super 0 is negative, it is spontaneous. How does delta G change with temperature? Delta G equals delta H minus T delta S for any temperature. If the absolute temperature is 0, then delta G equals delta H. What if we change the conditions? If delta H is negative and delta S is positive, then delta G will be negative at all temperatures. If delta H is positive and delta S is negative, delta G will be positive at all temperatures. This will always be a non-spontaneous reaction. If delta H is positive and delta S is positive, then delta G will be positive at low temperatures, but it will be negative at high temperatures. If delta H is negative and delta S is negative, then delta G will be negative at low temperatures this time, but positive at high temperatures. Let's look at how the free energy changes with equilibrium. Delta G equals delta G super 0 plus RT, the log of the quotient, Q. R is the gas constant, 8.314. T is the absolute temperature, and Q is the reaction quotient. At equilibrium, delta G will be equal to 0, and Q equals K. So, delta G super 0 equals minus RT, the natural logarithm of the constant. This shows the relationship between delta G super 0 and K.